Today I'm going to talk about sharding. Often when we talk about sharding, people first say, so what's a shard? What does that mean? And the definition is a small piece or a part, although unfortunately most people, when you think about a shard, you often think about broken glass. Got a shard in my finger, a shard in my eye, things like that. I prefer to think of it as a small piece or a part. And as we talk some more tonight, you're going to see where a small piece or part fits into how we're going to talk about scaling our applications. So what is database sharding? So database sharding is a pattern where the rows and documents are spread between different servers to scale the data source beyond the technical limits of a single instance. Hopefully that's the last thing I'm going to read off a slide, because I personally hate people who just stand up here and read off of slides. When you look at sharding, what you find is a lot of these systems that fall into the internet scale things, and thus the reference to the Mongo. If anybody didn't get that, that's the Mongo video that was around, about a decade ago. Lots of internet class services do sharding underneath the covers for you. And you'll notice I use Datasource here. While a lot of sharding talks about databases, reality, you can shard pretty much anything. Give you an example. Worked on an application where the S3 buckets were sharded. They knew that either having one massively large S3 bucket was too big, too risky, or they had concerns about the performance. So instead of just sharding the database, they actually sharded access to the S3 buckets, depending upon what data they wanted to put in there. You'll also see sharding these days talked in the context of a shared nothing architecture. One of the reasons for that is when you look at your shards, you often have them dedicated hardware, isolated inside of your network, isolated inside of your VPCs, so that if something was to go down on one part of it, you're not losing everything. All right, so let's talk about why I'd want to shard. And don't worry, in a little bit I'll tell you why you don't want to shard. Most common thing you hear about for sharding is, I'm sharding because my underlying technology just isn't scaling the way I want. I can't get enough CPU, I can't get enough I/O. Or, and this is an interesting scenario that I heard a couple years ago in talking with somebody, they have a technology that they want to use, but they know it isn't going to scale. Graph databases was the example that I spoke with a gentleman about a number of years ago. They loved the graph databases. It solved a very specific problem for them, but they knew there was no way they were going to put millions or billions of nodes into these databases, this database, and have it scale in a way that they wanted. So they were asking, well, how do we have the application distribute the data store without having to put a lot of complexity into the application tier? Oh, and by the way, if you have questions, a couple people in the room are monitoring the YouTube channel. So if you want to post there and ask a question, they'll interrupt me, and I'll see what I can do to answer your questions. The next one's an interesting one. It's not a technical problem, it's a business one. So if your database takes an hour to recover if something catastrophic happens, and the business says that's not acceptable, you can't run the risk of saying, oh wait, we're going to be down for an hour because it takes this long for us to handle the redo logs. Yeah, a great 64-core database with running on Oracle is awesome until you have to do a hard reboot because somebody shut all the power off in your rack. Not that that happened to us. So sometimes you want to shard because your mean time to recovery is an important business metric, not just a technical metric. Sometimes your cost models may lead you to sharding, where depending upon the type of customer you have, you want to give them different resources or different size databases or data stores. So sometimes people look at sharding as an option to say, I'm going to put my demo accounts over here, I'm going to put my people who are paying me a lot of money over there, but I really don't want to redeploy an entire app just for them. I want to do my data stores. We'll talk more about that later when we get into a discussion about sharding keys. Regulatory or costs is another interesting scenario for sharding. So let's talk about regulatory. If you're in an industry that says, hey, you need to maintain data for 10 years for clients who no longer are paying you because the end user needs to be able to come back to you and get access to their quarterly report from 2018. Rather than building out an entire application whose purpose is to deal with this old data and have it be completely different than the application that's dealing with the current data. Even though they run the same queries, maybe they execute the same underneath the covers, you can implement a sharding model where those customers who are no longer paying you access cheaper, slower disks or cheaper, slower application servers because they aren't, like I said, they aren't paying you so much. We'll talk a little bit more about that as well. And finally, the complexity of the horizontal scaling just isn't worth it. When we talk in a little bit about the reasons why you don't want to shard, one of them is that this adds a fair amount of complexity into your application. But the complexity of doing a good horizontal shard also has to be taken into account. And what we mean by a horizontal shard is in one application, in one data store, you have multiple database tables, you have multiple instances of the database that the tier above it has to know how to go and consolidate. If getting that right in your business is more expensive than being able to say, I have data here and I have data over in that other server, sharding should be worth considering. Okay, when we think about sharding, there's really three common types that come to mind. The first, which is the application level, isn't really sharding, but often in the conversation about how do I scale, you have this conversation. So the idea here is you build out an entire instance of your application, dedicate it to a set of clients, and it's all for them. It's often, as I like to joke here, pod1.mycompany.com. You sign up as a new client, we're told, hey, you're on pod 1. Hey, you're on pod 5. Hey, you're on the European pod. It's not really application sharding, it's more deploying the app in multiple places. But sometimes, especially if you've got a really good DevOps pipeline, that might be a much cheaper answer than going and saying, how do I shard at the data source tier? The next is actually at the database level. This is where you look at your entire client and say, I'm going to put them on a database. So over here, my US East 1 instance of Aurora, I have these 100 clients on it. Everything about that client is on that data store. The Java tier is the thing that knows, they're over there, so I'm going to call the US East. For this different client, I'm going to go over there and call the US West. Interesting, but honestly, I don't like this model because you're in effect doing the first application without the ability to be as redundant as you need to be. Because if pod 1 crashes, only 5%, if you say you got 10 of them, only 10% of your clients are down. But in this model, if you lose your application tier, everybody's down. So let's talk about the fun one. This is where you get into microservices, and you let each of your microservices define how they want to shard. And when we get into the key discussion, you're going to find, we'll talk about how interesting this can be because the services may have a completely different view on what they need to do to shard their data, whereas a second service may view it completely differently. So we'll talk about those in a minute. Let me pause. Are there any questions? We're good? Okay. So do I need to consider sharding? While this presentation is about sharding, I'm going to spend the next couple slides trying to convince you not to do it. And I'll be blunt because this is a non-trivial change. There's going to be operational costs, there's going to be CapEx costs, there's going to be complexity things that you need to take into account. But reality, if this is the solution, we'll talk about ways to know if this is the solution. Sorry. One of the most common reasons I hear about why I need to shard is I don't have write throughput. So I'm up there, I'm on Amazon, I've bought my small instance, and I just don't have the write throughput I want. So first question is, well, why not? I mean, I can go and spend a few dollars, get some SSDs, spend a few dollars, spend a lot of dollars, get a Scale I/O, or we'll talk in a second about the enterprise licenses, go buy some enterprise licenses. So here's where, just because I have technology and I can do this at the Java tier, you really need to ask yourself, is this the right use of my time, my resources, and my money? Because honestly, if you go and install a Scale I/O out on Amazon, you're going to get 120 IOPS, 120K IOPS, 200K IOPS if you spend the money. So is that worth the cost month to month versus going off for 6 months with your whole team and refactoring your whole product? It's a good question. It's one of the things you need to think about as you're thinking about scale, sharding. The enterprise license one is interesting. A few years ago, I would have said, no, don't even consider enterprise licensing. Why? But what changes since then is that the big the big cloud providers have started to implement versions of open source things like a Redis, like a MySQL, that give you good performance. But then the vendors come along and say, you know what, we will give you better or great performance if you buy the enterprise license. Similar to the discussion about SSDs and Scale I/O, look at your cost and decide, is it better for me to go and get an enterprise license in order to solve my problem and be done with it? Okay, this isn't working at all. Okay, the other, sorry, wearing a mask all day, a little dehydrated here. The next question to ask is, well, if write I/O isn't your problem, have you really invested in the caching and the read replicas to solve this? Amazon in particular, we're an Amazon shop, so I know a fair amount about read replicas in Amazon, makes it fairly cheap to put read replicas out there. Now you need to do some application changes so that your app knows when I'm doing read-only things versus doing things that require transactions, but that's nowhere near as invasive as deploying a completely new set of databases and implementing a sharding solution. So spend some time and ask, do I have the read replicas? If I add more, is it worth the money I'm spending? Did you try? This is one. We were talking right before with some of the other folks in here. Have you actually tried tuning what you have? One of the things that I learned a long time ago, because it surprised me, is there are people that you can hire that will come and look at your problem and give you a completely unfiltered view of what is wrong and maybe even help you solve it. Personally, in my career, I wrote a check for $10,000, which, trust me, back then was a big amount of money in a startup, to bring in some folks who looked at what we did and said, by the way, change that, change that, change that. And we gained a significant amount of performance because we just didn't understand what we were doing. Also convinced some people we need to go hire the people who can tell us what it is we don't understand. But asking the question of, hey, do we have the right thing? We may not be the smartest people in the room. Do we need to go find the right people? Do we need to go find the Gandalf that can look at the Oracle, that can look at the Redis, that can look at the MySQL and give us some better feedback? Also, another one that we've talked about sharding that people I've met with have said, well, in the end, we didn't end up sharding. Instead, what we did is we looked at the application and said, why are we doing all this write I/O? Or why do we have all this in that kind of data store? If we're going to go spend this amount of time to re-architect, should we be looking at other things? Right? Maybe there is a better solution now than there was when you built this app. Maybe there's a new version of something that solves a problem that you've been having all along. So spend some time and ask the questions, are we doing this right? Now, I know that sounds flippant of, oh, just go re-architect your thing from the beginning, but sometimes looking at a requirement and saying, how would I do it now instead of what I did 5 years ago, could allow you to change and do it in a way that isn't completely disruptive to your business. You're not starting all over, but to allow you to make a change that doesn't require you to go to something that's complex. Are there other aggregations or pre-processing that you could be doing to allow less data source activity? This, again, that's not the way we did it in the past, is a conversation worth looking at again. Just because we didn't pre-calculate something, just because we didn't do X, is doing that now appropriate? And the last one's one of my favorite stories. We're a startup. We had a database. We were running, and every month, at the end of the month, things got really slow, and we could never figure out why. Next month, we thought we had it solved. Next month rolls around, still got a problem. Couldn't figure out why. So we finally started asking, okay, what else is going on in the box? What we found is, in the interest of saving money, the IT department had put another app on our database. And guess what? It only ran at the end of the month. And it was heavy. We never saw it up until that last week. So finally, as we started asking the question of, okay, so what's all this I/O? Where's this coming from? This can't be us. Finally, somebody goes, oh yeah, you guys remember that app we deployed? Yeah, well, guess what? They took it off, and all of a sudden, we had another year's worth of growth room left in that database. So again, ask the question, what else is going on that makes me think I've got a shard when it's possible that it's not even my app, it's things that are going on around me? Any other questions? Nope, still good. Okay. Other benefits of sharding is it gives you the options to scale independent services in different ways. So give an example. When we talk some about shard keys in a minute, we're going to talk about demo accounts, we're going to talk about test accounts. And if you decide that that's going to be one of your shard keys, one of the things that you may decide to do is build a very small, non-redundant, no-read replica instance for those accounts. If it fails, it fails. It's a demo account. Nobody's paying you. It's a test account. Okay, yeah, you'll slow down your next deployment, but it doesn't hurt so much. If you had to put that same volume, those same number of users into your production environment with the replicas, with the geographic distributions, it can get expensive. This next one, while it is a benefit, I beg you don't do. Please don't do. Multi-tenant SaaS is what I think we're all building. I know many of the folks in the room, as well as a couple of people that are watching this live, are multi-tenant SaaS companies. We make our money because we don't do customizations. Everybody gets the same marketing application, the same HVAC monitoring system, all of that. We all get the same thing. But if you're a startup and the guys who love to drive brown trucks show up and say, all right, we'll give you $5 million a year if you do it our way and segregate our data, you go, yes, sir, may I have another, and take the check. If you don't have to do it, don't use that as an excuse, or as a reason when you go to your boss to say, here's why I want to do it. We're going to allow us to do customer-specific retention, because you will regret it in a decade. Trust me, having been in the same place for 18 years, some of the decisions we made at the beginning, as I walked out the door, I was like, oh man, I still can't believe we have to support that. Arguably, your application becomes less complex if you choose the right keys. Remember we talked about horizontal sharding before. If your answer is horizontal sharding and your query tier has to know, okay, it's this customer, so I have to join table customer _1, _5, and _11 together to get my data, because I can't build a single table big enough to hold all of that, and which is really a problem in IoT and some of the other industries, maybe you should be looking at how do I not do that kind of scaling and instead have the app tier know my data is over there in US East 1, but for the other clients in US East 2. The other one is, surprisingly, a lot of technologies support this natively. If you're a school teacher and I say Wikipedia, please cover your ears, but if you go to Wikipedia right now and you look up database sharding, there's about 30 companies at the end that list products that implement sharding under the covers. The vast majority of which, if you look at them, you'll be like, oh, okay, maybe that is how they do their internet scale. Maybe that is how they are able to solve the problems that they solve. Okay, downsides. So the biggest one is this guy is seeing my talk tonight, and at DevNexus next year, he walks up, hands me an SSD, and walks away. Because maybe the answer to your problem isn't to shard it, is to just go buy some hardware. Anybody who doesn't know what that guy is, go look it up. It's hysterical. He makes the influencers look ridiculous with the things he does. And if you don't know what I'm talking about, post a comment in the link, in the YouTube, and I'll post a link to this guy's videos later. He's hysterical. Other downsides. Again, remember, I'm trying to talk you out of this, but at the same time, I'm encouraging it. So I want to make sure you've got a clear vision of what you're getting into. You may not actually have the cost benefits. So when you think about sharding, and I'm going to deploy a new database that is specific to this 200, 500 clients, that comes with cost. Well, read replicas cost. I/O between zones costs. There's going to be a point where if you invest in too much hardware, you're going to wind up spending more than if you just built a bigger or a couple of bigger boxes. So as you look at your sharding approach, first ask the question of, yes, if I have to shard, how can I do it with the smallest amount of hardware? How do I do it with the smallest amount of databases, other data sources? Other downsides to this is operations complexity. What is your resiliency model? If your resiliency model allows that a certain percentage of your clients are offline for a period of time, you can drive your costs to that. You can drive your design to that. If your resilience model is, hey, we can't do that, we need to have availability up in a 3.9 or a 4.9 kind of thing, look hard at what does it mean for me to have all of these shards when something goes wrong? Do I need to send an ops person to go figure out what is wrong with all of the clusters that are out there? Or am I looking at 2 or 3? The next one is your backup and DR model. Now, resilience and DR are definitely different things. So what is your DR model? If it requires you shipping all of this data all the way to an availability zone on the other end of the country, look at your costs. Is Amazon going to gouge you because you're not replicating a database, you're replicating 10? And what does that wind up doing to your costs? I talk a lot about costs because sharding isn't just a technology solution. It's got real cost to it, but it also has real benefit if those costs make sense in your business. Automation of deployment. How many of you guys use Liquibase? Right? Liquibase is a very cool, especially in a microservices world, where I can build my microservice that owns its own data source. I've got a Liquibase script on it. When my service comes up, it runs, connects to its database, says, okay, all my tables exist, all my indexes, everything I expect exists. Well, but what if I've got a dozen databases? How does my application know to reach out to all of them to make sure they're all consistent? Because you want to really screw up things, don't have consistency in your data models for all of your shards. That gets really ugly really quickly because how are you going to find it? Somebody's going to have to manually go through and look at everything, do dumps and do comparisons of DDLs and all that. So as part of your deployment automation, you have to come up with a new way. Now, what we came up with, and I'll give a shout out to Rudolph here if he's watching, is we have a script that looks at the Liquibase scripts for all the deployed services and is aware for that service what its shards are, and using Spring Cloud Config, iterates through those Liquibase scripts for all the databases. And if it succeeds, then the release continues, application comes up. If it fails, well, pagerduty. Start calling people to figure out what just happened. Last one is interesting. DBAs, they do management, right? They have to do maintenance. They often, I don't care how much you just paid to Oracle for one of their enterprise licenses, you still occasionally have to do partitioning or do some other work on the database. Well, now it's not just one database, it's many. Also, now instead of being able to scale down one application's database that isn't using so much resources because, I don't know, it's been 10 years since you deployed and your client base is now spread across all those shards, I now have to have operations involved to say, okay, I'm going to take this shard, I'm going to merge it with this shard, I now need to stop routing traffic to that, I now need to update the Spring Cloud config, I need to do all of these things that in the past you just said, okay, online rebuild that Oracle table or that MySQL table, and things were happy. Let me pause there. Any questions? Okay. So there are some other downsides. This couple technical things. Hold on, let me grab a sip of water. Cross-shard queries are very difficult. While your service may be built to own its own database, there are going to be times when somebody's going to come along and say, hey, I need to find this information out. Rarely is it your application that needs this data. Sometimes it's sales, sometimes it's marketing, sometimes it's your product team who say, hey, how many people are actually using this feature? And if those aren't things that you thought about ahead of time, you're now going to have to write something that knows how to reach across all your shards. Now, since you're in the cloud world, hopefully, the first big problem is I have no idea where these databases are, right? My Spring Cloud config hid all that from me. AWS hid all that from me. I have no idea what my passwords are, because again, as soon as I deploy that database, we step all over the OAuth tokens, regenerate the private keys, so that password is no longer useful. The one I had in my hand last week, when I just deployed everything, got reset. There's a lot of complexities if you now have to reach across all these shards for something. Now, that shouldn't be a knockout unless your design is relying on that level of cross-shard queries, and then maybe you got your shard keys wrong. The SLO, SLAs are really hard to define and monitor. Remember we talked before about different instances, different sizes depending upon the clients, and we talk about keys in a minute. You also see where this fits in. It becomes really hard to know where your problem is. So how do you define an SLO when I've got 10 different databases with 10 different client types, possibly with 10 different sizes, different read replica models? What do I do? So the biggest piece of advice I've got here is to pay attention to what your dimensions are in your metrics. Include your shard key in it. If not the shard key, at least the data source that you're connecting to. So you can build a query against your Splunk or against your other tools to say, hey, what is going on in this particular instance, or which particular instance is the one that's having problems? Another fun one, thankfully this didn't happen to me, but this is one of the comments I got when we talked back in March about this, is when you provision a new shard, make sure you automate the monitoring side of this as well. There's nothing worse than deploying the shard, being up and running for a couple months, having a problem and everybody going, well, the metrics show everything's great. In reality, the metrics completely missed this other shard we created. Tie them together. Don't rely on humans. Automate, of course, DevOps, automate the pipelines. Automate the pipeline to know that you're monitoring when you bring that service up. It's not somebody, hey, Monday morning, go ahead and add the monitoring back in. Make it as part of the pipeline. Okay, so let's talk about shard keys. Now I've talked about the pros, I've talked about the cons. Let's get into some implementation details. In effect, what we're doing here in sharding is looking at some kind of a hash function, and that can be as simple as a round robin. It can be as complicated as go look up in another data store for this client ID, where's their shard for this particular service. But the idea is you want to go ahead, identify your hash function, and then figure out at your Java tier how to route your requests to those shards. A little bit of a teaser here. You notice the read replicas here. The read replicas are not changed by the hash function. We'll talk in a few minutes about how, by having a hash function and implementing it using Spring, that you can go and get to your read replicas without having to have a different hash function depending upon which type of transaction you're doing. Oops. All right, so let's talk about some common shard key examples. The first and probably the most common is the tenant identifier. Somewhere in your system, you've identified whether it's a single user or more likely, as a lot of folks who develop enterprise application, there's an organization or a client identifier. That's probably the most common of the shard keys when you think about within a service. So all of my information about this particular client is in US East, this other one's in US West. Another one is a time-based. And this is an interesting one if what your service is doing is very short-lived. So if I've got a application where my service, again, not the entire application, but just this service, is able to look at the data that's coming in and put it in a specific bucket, knowing that I'm going to come ask for it by that date or by that time range, and we'll talk about retention in a little bit, when the time is up, I can just shoot it and it goes away. I don't have to go into my database and select star into or delete from or do reorging online. I can just say, Mr. Data Source, goodbye. Client type. So this is where I first got involved with looking at sharding, was we do a lot of demos, we do a lot of test accounts that don't last for very long. People come in, they want to try our stuff, and it gets expensive to clean up after them, because you really don't want to leave them out there. Even if you've got a data source that does indexing really well, it's still disk. It's still I/O to read through the pages. There's still a lot that goes on there that you just want to get rid of it. Now, the challenge with this one is that demo account may go, wow, this is the greatest thing ever. I'm going to take all 5,000 of my users and move it over to you, and we're going to do about 1 gig of traffic a month on you. Yay, sales. But now you got to think about, how do I take that account and move it over to the paid model, or in the marketing world, what one of my clients once joked about is the martini holders. For those who don't get the reference, in marketing, they like to go out and have martini lunches. And I had a client who very specifically said, I want your people in my office to do whatever I want them to do, including if when I'm at lunch, I want them to hold the martini until they refresh it. And I started laughing, and everybody was like, I think he was serious. He wasn't, he was joking, but for years then, people I worked with referred to those as the martini holders. So as you think about your shard keys, also think about the type of client that you're going to put on top of it and what benefits you could get by segregating those client types. Another one that comes up a lot in Internet and Things these days is a data point specific shard. So think about the things that your application is creating on the behalf of your clients. A webinar, a video stream, a marketing campaign. Things that the vast majority of what you are interested in is all tied to that key. It isn't necessarily to the client, it's to the key. So when you ask the question of, well, how many people opened my message? How many times did the temperature deviate by 10 degrees? All of that are things that fit nicely into a data point specific shard. So don't just think, oh, I've got to put this tenant who's got 500 gas stations around the country and I'm monitoring their HVAC systems. Don't say all 5 of them have to go into the same shard. Maybe just each store. Heck, if it's a big enough thing, maybe just each IoT device. The HVAC system for the 2nd floor versus the 3rd floor. When you think about your shards in terms of my microservice and what my microservice is doing, you've got a whole bunch of options that you didn't have before, when all you had underneath you was a big relational database or a single data source to play with. Let me pause there. Any questions? Okay. I've talked about this a few times, but I love this movie. In fact, I'm going to try this weekend to introduce my son to it. Just because I could shard the whole application doesn't mean I really should. Inevitably, I have a conversation with somebody about, well, why would I do this to that particular app? We only generate 4 rows for the customer. It's almost pure lookup. Then don't. Again, go back to the idea of the microservice. If I don't need to shard that, and operationally the ops team is okay with us saying, okay, this is the database for everybody's statutory policy lookup, and they're okay with that, and the business is okay with that, because if that goes down, what happens? Well, but if it goes down, maybe you invest in some heavy-duty replication. Don't shard it. Not everything is sharded or shardable, nor do you need to do it every time. I thought about using this one, but I wasn't sure how much of the audience was going to get this. Does anybody get the reference? No? Okay, I didn't think so. So this is a car person thing. LS or Chevys, and Chevy lately has said, hey, we built the small block that everybody loved. We now have this new model called the LS. Let's swap an LS into everybody in the world. So the idea being that regardless of what your vehicle is, you need to put an LS motor in it. Personally, I'm a Ford guy, so I want a Coyote. Yeah, I was afraid that wasn't going to go over too well. Sorry. All right, so let's finally talk about some Spring stuff. So the guys who built and people who built Spring are very aware of this need. They do it for other reasons, but the abstract routing data source makes this trivially easy for you to do in your application, where the only thing that knows that I'm pointing to US East instead of US West is a single point whenever you ask for a database connection. So we're going to pop out and we're going to look at some source code. How's that look? Okay. I should have zoomed this up before. I'll point to the most important part. So this is a filter, right? I've got a once per request filter. And the most important part is the block inside of the try. Basically, in our header, we are including the organization identifier. We get the header. We ask a service, hey, what is the hash for this organization? It replies back with a data source shard and I'll show that in a second. And then we set it. In this case, it's using a thread local, but there are reactive ways of doing this as well. And then we continue with the filter chain. So at this point, we have told Spring, hey, you're not going to be using US East. You're going to be using US West for this particular client. And by the way, here's the thread local. I mean, this is trivial. Again, I apologize. I should have made that bigger before we started. It's trivial. I set a object in my thread local. I get it, I set it, or I clear it. I mean, how simple is that? Yeah, I know thread local, but this works out nicely. But here's where the actual Spring call happens. By the way, this is the whole thing to make sharding work in Spring. Spring will call this service and say, okay, determine the current lookup key. You give back to Spring the name of the Hikari connection pool, and it starts using it. It is that easy to get Spring to route to different databases. Now, remember what I mentioned before about read replicas? A lot of people struggle with how do I add read replicas to my application. The trick to the read replica, go back to my presentation, is you can put an AOP around @transaction or read only. And Spring will make sure that your AOP is called before it tries to make the call to that abstract router. So you have the opportunity now to catch and say, hey, wait, they're in a read-only transaction. Because what is a shard is not just a database connection pool, it can be other information. It's trivial to enhance that code we just looked at to say, hey, wait, if it's read-only, return the reader. Oh, poorly named. Return the reader name to Spring instead of the writer name, and now your code is using a read replica. Now, reality, you got to test this. You got to write some good unit tests. There's no tests around this. It's just an example to show how simple it is. But hopefully this has got you thinking, wow, all that stuff I did to figure out read replicas, that was kind of overkill. Or, wow, I'm afraid of deploying multiple data sources because I don't want to have code that says, if it's this, connect to this Hikari pool. If it's that, connect to the other one. Spring makes it trivial to do. And that was my presentation for today about sharding. So, anybody have any questions?
We're about a 2-minute delay, so.
Okay. Right at 40. So by the way, I showed both of these to my kids and asked them which was cuter and which one I should use, and being grumpy, they were like, I don't care. So I put them both. I personally like the one on the right. This is a nice small group. I'm not at work and having people feel that, wow, I was a little arrogant saying that I killed the presentation, but I kind of like that one.
You're right.
So, so you said there's about a 2-minute delay?
Yeah.
Okay.
I just asked the audience for questions.
So,
Is this on?
if not, I can repeat it.
I know we're on a delay, but if you have any questions, feel free to ask, and I will read them out.
Wow, that battery went quick.
So I guess one question would be,
Yeah.
have you found any particular issues with maybe sharding across different database types as far as performance or issues that have occurred?
Sure. So the question was, have we encountered any performance challenges across different database types when we shard the different types? The biggest one you got to be careful about is the SLO definition. So if for your demo clients who are on a smaller box that you're not going to put a lot of money into, do something dumb. You got to be able to respond and say, okay, while they did something dumb, I need to make that stop. The other thing to do is as you look at your, the way in which you spread stuff around is figure out, can I actually provide the SLO that I would for a regular user on that smaller box? So if I've got a box that I've dedicated or that's for the, the real clients and I'm getting, 80 millisecond query times, and I've got a smaller box that I've got my demo clients on and I'm at 100 milliseconds, is that okay? If it's not, then you probably need to make sure that you size them similarly, but don't do the overhead of the additional read replicas, the additional redundancy, all that kind of stuff. But there's also times when you put the big box for the client type that you know is going to do a lot of things, that you can match the same performance as you're giving to the smaller guys because you've thrown a whole lot of hardware at it, or you've indexed it significantly better.
Okay, this question's coming in. Is there any benchmark info regarding the max volume of data we can have in a single database before looking for sharding?
So question is there some benchmarking to figure out whether it's time, if there's enough capacity on a specific box to start thinking about sharding? To me, that comes back to what are your SLOs and what are the commitments that you've made to the business. If 250 milliseconds for a query is fine with the business, great, then don't worry about it. But if it turns out it's 50 milliseconds, or your IOPS are continually bouncing up against your limits, and as you do your tuning, you realize you've got an IOP problem. So I really don't think I can give a benchmark that says, when you hit X, think about sharding. I would first go through everything that you can do until you shard, because shard should be the last resort. It is great, it does scale nicely, but there's a lot of other things you can do before you go into this other complexity.
Have y'all done any experimentation with reactive-based data sources or?
So yeah, the question is, have we done anything with reactive-based data sources? I have not, although I saw Hibernate 1.0 got announced, 48 hours ago, something like that, over the weekend. I'm going to set aside some time next quarter to go and play with that. I think it's the fact that Hibernate went to a 1.0 after 30 years or 20 years of 0 dot somethings suggests that this is something they're very confident with. So I'm looking forward to playing with it, but personally I have no experience with that.
Okay, I'm going to give about 1 more minute.
Okay.
Any more questions from the audience? Okay. And we're just going to give our folks online just one more second to ask a question. And then we'll call it a session, folks.
Great. Well, thank you, everybody. Thanks for all that came out. Thanks to everybody online. If you did make a comment online, I'll check tonight about the gentleman with the hysteric influencer videos. For those that don't know, basically this guy watches you do a really dumb influencer thing and then makes you look ridiculous. Like, they build this huge smoothie thing and it takes 4 hours to make it, and he walks up and he hands them a Jamba Juice, things like that. So like I said, he saw this presentation, looks at it, walks up and hands me an SSD, because I should just bought an SSD instead of sharded, right? Great. Well, thank you, everyone. Appreciate everybody to come out. Have a good evening.